Today I want to talk about a really cool proof for the Pythagorean Theorem. It was created by US President James Garfield. He was a president after the Civil War. He's a really interesting figure. He created this proof while he was actually in the House of Representatives, US House of Representatives. It's a really cool proof. So what is the Pythagorean Theorem? It's a theorem relating the sides of a right triangle. So imagine the hypotenuse, the long side is C, and the other two legs are A and B. If you square the other two legs, it should yield the hypotenuse, the longer side, opposite of the right angle. So this is how James Garfield proved it. He drew a triangle, a right triangle, and let's with A over here and B over here. And then imagine him rotating this. So he rotates it in a way where this becomes A. He rotates it in this way, and this becomes B. And as these are it's the same triangle rotated, this should be the same. So he connects these sides and he creates a trapezoid. So imagine this is x and this is 90 minus x, because that's how a right triangle is. When you rotate this, this would become x. So 90 minus x plus x is equal to 90 degrees. So that leaves 90 degrees for this angle, because a line is 180 degrees, so 90 degrees. So now what he does is he tries to find the area of the trapezoid, and in doing so he finds the Pythagorean theorem. Here's how he does it. So first let's find the individual pieces of the area of the trapezoid. So this triangle, if you want to find that area, it's A times B, the two legs, and then you divide it by 2, as that's the area of a triangle. And the same thing with here. And then for the final triangle, it's C times C divided by 2. And then the area of a trapezoid is, let me make a better trapezoid that's oriented in a more familiar format. This is the base 1 and base 2, and this is the height. What you do is you find the average of the bases and multiply it by the height. And in this case, it's hard to see, but if you rotate it in this way, you can see that this is just a trapezoid, but it's oriented differently. So we can use the same formula for that. So the bases, which is B and A, you find the average of them, which is A plus B divided by 2, times the height, which is A plus B. A plus B. And then, because there's 2, you multiply 2 on all the sides. And then that cancels all the 2's on this side. So this is AB plus AB plus C squared is equal to 2AB plus C squared. And if you multiply the 2's, this cancels out. So essentially this is A plus B whole squared. And you need to know how to expand a quadratic, which is key to solving this problem, which is A squared plus 2AB plus B squared. And then you just subtract the 2AB, and this cancels out. And what you're left with is C squared is equal to A squared plus B squared, the Pythagorean theorem. Now, isn't that cool?